Welcome to
Math problems number 154.
Math problem number 154, powers of 2 and decimals. So we're just in our second day of talking about decimals and fractions, and you noticed a very interesting pattern that I wanted to talk about. So let's review real quick, and then we can say what the pattern is. What is 1/2 as a decimal?
It's 0.5.
0.5. What's 1/4 as a decimal?
1/4 as a decimal, it's going to be half of that.
Okay.
So 1/4 as a decimal would 0.0. It's not 0.05.
It's not 0.05, no?
So, but it's going to be half of that.
Yeah, it's going to be half of that.
But half of 5 is it's 2.5. Because
Yeah, half of 5 is 2.5. So what's half of 0.5?
0.25.
0.25. Okay. About 1/8.
1/8 is 0.125.
You notice that that's half of that?
Yeah.
Yeah.
But and all of the
oh, go ahead. Go ahead.
and then this is, I think it's 0.625.
Actually, 0.0625.
Oh, yeah.
Okay.
But there's
Because it's half of this, so half of 0.1
half of,
is going to be 0.05, and then half of 0.2 is 0.01.
yeah.
Okay. Now, what did you notice about these numbers?
Well, all of these powers of 2 have all of the powers of 5. 5, 25, 125, 625.
Yeah.
And 1/32 will have the next power of 5.
Should be 0.03125.
Whoa, that's gonna be pretty small.
Yeah, that's pretty small. 0.03. So it does have powers of 5. 5 times 5 is 25. 25 times 5
is 125.
125 times 5 is
625.
625 times 5 is
3125.
whoa. I wonder why that's happening.
I don't know.
Huh. Well, what is 0.5 as a fraction?
It's a fraction. It would equal here 1/2.
Yeah. What else is it as a fraction?
That's a fraction. It's like 2/4 and 4/8.
Yeah, but how about in terms of tenths? Say, what is it?
5/10.
This is 5/10. What is this as a fraction?
Well, that's a quarter, so that would be maybe like 3/4.
Well, not 3/4.
Well, it's 1/4.
1/4. And what can we write it in terms of a 10?
A 10.
Or powers of 10?
I think it's 10. I think it's It's 2.5. I think it's 2.5 over 10.
It's 2.5 over 10. And what is it over 100?
Over 100, it's 25 over 100.
25 over 100. So this is 5 over 10. This is 25 over 100. What would this one be?
It would be over 1,000. It would be 125 over 1,000.
125 over 1,000.
This one would be 625 over 10,000.
Uh-huh. And what about this one?
3125 over 100,000.
Okay. And now we're going to start to see why we see this pattern.
Well,
10, remember this is 1/2,
yeah.
right? This is 1/4, this is 1/8, this is 1/16.
1/32.
Okay. So this is 5 over 10 is 5 times 2, right?
Yeah.
Okay.
But
So what do I need to multiply by to get this equal to 1?
To multiply by, to get that equal to 1, you need to you need a 2 on the top so they can cancel.
Right, so I'm missing this 2, so I would need to say this is the same as 1/2. Either you can say the 5's cancel,
Yeah.
or I'd have to bring this 2 up here. I have to cross multiply, right? This is 5 squared over 100.
Which is 10 squared.
10 squared, which is 2 squared times 5 squared. So
And
what?
then again, you need the 2 squared.
You need the 2 squared, which is 1/4.
And that,
So you see where the 5 squareds are coming from, and
yeah,
here's 5 cubed
5 cubed.
over 2
Over
cubed
2
times
cubes.
5 cubed.
And again, you just keep kneading that 2.
You just keep kneading that too, but you can see where the 5 cubed comes from, the 5 squared comes from, the 5 comes from.
Yeah.
This one's going to be 5 to what power?
That one's going to be 5 to the 4th.
And we just need a 2 to the 4th to make this equal to 10,000. What's 2 to the 4th?
16.
There it is.
And the next one you need 2 to the 5th, which is 32.
How about that? So this pattern that we see, 5, 25, 125, 625, 3, 125, isn't an accident.
No.
No, it's coming from how 10 factors, how 100 factors, 1,000 factors. It's coming from the prime factors of powers of 10.
Whoa.
Pretty cool, right?
Yeah.
All right. All right, that was fun. I'm glad you noticed that pattern. That's a great pattern. All right. Good job this morning, hon. Good